Hello everyone, my name is Alya Batrisyia. My metric number is FT251101147 and I will give a brief introduction. First and foremost, access to clean and safe water is one of the most basic necessities. However, urban and rural areas often experience very different levels of development. Urban households usually have pipe-treated water and reliable water system, while rural households may rely on rivers, wells, or untreated water sources. These difference affect health, hygiene, and overall quality of life. Lack of treated water can lead to waterborne disease, extra time spent collecting water, and challenge in daily living. By looking at this difference, we highlight a real-life problem that affect communities and point to the need for more equitable development. Next, our study focused on household access to treated water. Treated water is essential for drinking, cooking, and hygiene. By comparing urban and rural households, we can see gaps in infrastructure, government support, and overall development. This dataset helped us understand which communities are well served and which need more attention. So, the main aim to analyze the difference in treated water access between urban and rural households. Our guiding questions are: why do urban households have better access and what factors contribute to this inequality? By understanding this, we can highlight challenges faced by rural communities and suggest improvements that can make water access more equitable.
Hello everyone, my name is Mahfuzah Binti Padjiri, FT251101133. First, I will explain about how the dataset was set up in SPSS. The dataset was imported into SPSS and the main variables were defined. These include the region, whether households are urban or rural, the date of entry, and the percentage of households with treated water. With this definition in place, the dataset is ready for analysis. Now, let's see how the data is organized. In Data View, the dataset is arranged by state, and each state is divided into urban and rural households. For example, rural households in Sabah had 73% access to treated water on 1 January 2000. This setup makes it easy to compare regions and household types, and the data is now ready for Part C.
This table shows the frequency distribution of the access variable. There are 46 observations in total and no missing data. The lowest value is 52 and the highest value is 100. The value 100 appears the most frequently with 6 observations. The cumulative percentage shows how the data accumulates until it reaches 100%. Next, this table shows the distribution of respondents by strata. There are two groups, rural and urban. Each group has 23 observations, which means both groups represent 50% of the total sample. First graph is a histogram. This histogram shows the distribution of access values. Most of the values are concentrated between 90 and 100. The mean value is about 80.51 and the standard deviation is about 70.89, showing moderate variation in data. The next graph is OGIF, which is cumulative frequency curve. This graph compares the access values between rural and urban areas. The blue line represents the rural group, while the red line represents the urban group. We can see that rural values are mostly between 52 and 79, which indicates lower access levels. On the other hand, urban values are mostly between 88 and 100, showing higher access levels. This graph clearly shows that urban areas have better access compared to rural areas. The last graph is frequency polygon. The frequency polygon connects the midpoints of each class interval to show the distribution patterns of access values. The graph illustrates how the frequency change across different values and help visualize the overall distribution trend. What about the mean? The mean value shows the average access score. The overall mean is about 80.51. However, when we compare the groups, the rural mean is about 64.4, while the urban mean is about 96.62. This indicates that urban areas have much higher access compared to rural areas. And the standard deviation shows how spread out the data is. The rural group has a standard deviation of about 9.39, while the urban group has about 4.9. This means rural data varies more, while urban data is more consistent. And how about the quartiles? Quartile divide the dataset into 4 equal parts. The median represents the middle value. The rural median is 61, while the urban median is 99.5. This shows that urban access values are much higher than rural values. Then, the interquartile range shows the spread of the middle 50% of the data. The rural IQR is 14.5, while the urban IQR is 10. This means the rural values are more spread out. Lastly, I will talk about the side-by-side box plot. In this page, they have a side-by-side box plot that I have put in this page. The side-by-side box plot compares rural and urban access values. The urban box plot is higher, showing that urban areas have greater access values. The rural group also shows more variations in the data. That's all from me, Jesslyn Reska.
Hello everyone, my name is Umay Slyvanus. My matrix number is FT25110154. Now, let's move on to the discussion of our findings. First of all, looking at the key patterns, most areas in Sabah have high water access, mainly between 80% and 100%. However, there are still a few areas with lower access, around 50% to 60%, showing that not all communities have equal access. Secondly, in terms of skewness, the distribution is slightly left skewed due to these lower values. For the group comparison, rural data is slightly right skewed, while urban data is slightly left skewed, indicating different patterns in each group. Next, the comparison between groups. When we compare rural and urban areas, the difference is clear. Urban areas have very high and consistent water access, with a median of about 99.5%. On the other hand, rural areas have a lower median of around 61% and greater variation, meaning access is more uneven. Next, move on to the real-world factors. These differences can be explained by real-world factors such as a better infrastructure and facilities in urban areas, while rural areas may face challenges like remote location and limited resources. Lastly, linking this back to the kampung context, it shows that rural kampungs may still struggle with water access despite overall high coverage in Sabah. This highlights the need for improvement to ensure fair and equal water distribution for all communities. That's all from me. Thank you.
For the rural group, the mean water access is 64.4%, which shows a moderate level of access. The standard deviation of 9.39 indicates that access varies widely between households. The median is 61%, which is slightly lower than the mean, showing a small right skew. The IQR of 40.5 also suggests large variation among the middle 15% of households. In the kampung context, this may be due to difference in infrastructure, location, and distance from water sources. Therefore, rural water access is not evenly distributed and needs improvement. For the urban group, the mean water access is 96.6%, which shows almost full water coverage. The standard deviation is 4.90, meaning the data is less spread and most households have similar access levels. The median of 99.5% is slightly higher than the mean, indicating a small left skew. The IQR of 10 shows that the data is more consistent than the rural group. In the kampung context, this may be due to better infrastructure, centralized pipelines, and easier maintenance in urban areas. In conclusion, the SPSS results show that water access differs across strata in the kampung. Some groups have better and more stable access, while others experience lower access and wider variation. This means water distribution is not equal across the community. The study successfully answered the research aim by showing that social or area differences affect water access. Therefore, improvement in infrastructure and target support are needed to ensure fair water access for all residents.